All right, so my backdrop up to now, I'm Gridley, I'm in Santiago, Chile. Great to see you all. And thanks a lot for the invitation. And Sarah, Rose, fantastic work. I've only been able to be in a few sessions, but I'm really impressed. And great session this morning too. Great people. So look, I'm a technical kind of person. I'm a civil engineer, and I've worked on design, construction, permitting, operation, and closure of open pit and underground mines. And so my bent towards this will be very clear from my slides. With the focus is responsible raw materials. And so how do we enhance our mining planning to enhance sustainability? And why isn't my screen advancing? All right, there we are. I guess this is an unnamed open pit. It's just a generic off the web. So if anyone knows where it is, let me know, but I don't. I just want to ask the question here. Is this a waste when it's all done, when we're all done mining this, which looks like it's getting close unless they go underground? Is it a waste? Is it something to be managed as a waste, or is it a resource? And we'll look at this, say a generic downstream construction tailings basin from flotation mining. Is that a waste or is it a resource? I say that because we're talking about changing the paradigm, right? We're talking about the circular economy. We're talking about how to make people realize that what we call waste may not be waste. They may be resources. Now, we've heard plenty of talk here about mining in the future. There's been a reference to how resources become reserves or become economic. I know, excuse me, Anthony, if I get the wording wrong. But the point being that over time, waste can become resources. And this has to do with what's available, what's needed, what's affordable, but also has to do with environmental permitting, land availability, social suitability, all those other factors that make a potential deposit, which may have been here, was here beforehand, something that can be exploited or not exploited. And so my point being, the mine planning that goes into this sort of design is fairly traditional based on what I've seen. I'm not a mine planner, but I've worked in the design of and approval of mines, and I've seen what the mine planners do. And I've seen the parameters that they put in to build the mine plan for this deposit. And also mention when we look at this picture that these kind of installations in central Chile where I live are going to become harder and harder and harder to locate. So there may be, in fact, on paper, well more than 100 years of resources of copper for the companies that own those rights here, the biggest one being Codelco, the state company. And there maybe 100 years, or one of the articles I saw recently indicated almost 200 years of resources. But that's not 200 years of space for tailings. The copper we're mining at this level is, usually below 1% grade. So everything is ending up in a deposit like this. Can't be sustainable. This can't work in the long run. So something I'm pitching here is to say, why should mine plans be designed? Well, current day open pit mine pit planning considers these variables as a minimum. And please correct me if I'm missing anything, anyone who's doing mine planning, but I know we have to consider, after we have the deposit, of course, and we know there's a deposit here, and we have the land rights, and we have the ability to go in here, say, we need temporary and permanent access. We need to move waste material. We need to dispose of it. We're going to recover ore. We're going to do pushbacks and benches and so on. We're going to design the pit for infrastructure limits, because we know that as the ore becomes maybe more exploitable in future, depending on the value of, we can say copper in this case, the pit may want to be larger. And we're going to do, with all of that, some financial modeling or analysis. We're going to do some financial analysis. And it generates a financially viable ore extraction program. It's effectively what the mine plan does from what I've seen, but it does not consider the excavated zone that we've made having value. It's considered an issue. It's considered a closure issue. And so why isn't it considered a value? Well, part of the problem is we're still working a lot, in most cases, with NPV analysis. So when we talk about mines that are going to operate, new ones, for 25, 30 or more years, bringing back the closure costs into present day value is almost unmeasurable in terms of its impact. And I consider that should be changed. This approach should be changed. What's the proposal I'm putting here? The very simple proposal, and has lots to do with timing of how these things are done. But add to the process the following. Well, consider the permanent placement of tailings. Can we put some tailings in that open pit? Sure we can. That's being done. It's not being done at a macro scale yet, but it's being done. Can we close the pit using tailings and other waste materials as appropriate to the scheduling of the pit? Sure we can. Can we reduce the long-term liabilities associated with those deposits? Well, of course. Maybe not eliminate them, of course. I'm not suggesting this eliminates liabilities, but it changes them. And then we would incorporate this tailings deposit modification in the financial model, or the economic analysis of the mine plan. What does it do? It modifies the mine plan in a way to provide the operation with alternatives to massive tailings deposits. Now, I say this from some personal experience I had recently on a project that's now under construction in Peru. It's called Quellaveco. It is a large open pit mine. It will generate this sort of hole in the ground. It won't look exactly like that. And it will also generate tailings. But after 24 years of mining, they will also move to place tailings and waste rock back in the open pit. And they will continue to operate with a stockpile of ore and use that open pit to recreate a filled area. Now, it doesn't look like this, but that will be partially filled when it's done. And that will be done with tailings and waste rock. So what I'm referring to here is a modification to the mine plan, not for the whole life of mine, all 30 years, but for 6 years of the 30 years. It's just one example, okay? That particular project, we've heard a lot about stakeholders and community engagement as well. That project did go through a very extensive stakeholder engagement process, or we could say interested party process, which included a dialogue table that was managed by the regional government. In that case, the Moquegua government. Very interesting work, and there's some papers on that, plenty of publications out there on that. And that included community and stakeholder engagement in the discussion of the closure plan. And in that case, the closure plan was agreed to be changed in the course of that dialogue process. The change was incorporated that I mentioned, a closure that would bring the pit back up to original water level, river level, and then eliminate in effect a pit lake. So changing the closure plan, something that in the NPV analysis is not highly measurable in terms of the decision of the company, but still a commitment of the company to do a lot of new things in 24 years' time. So I'm giving this as an example of how mine plans can be changed. I realize that this proposal is not something that people talk about today when they're planning a new mine. They look at the deposit. Of course, without a deposit, there's no mine. And then they look at land rights, and then they look at communities, and they look at all these things that come along. They do stakeholder engagement, consultation, indigenous peoples, if that's applicable. But how often do they say, how can we close this with minimum liability in the long run? And that's clearly what we should be thinking. We're talking about responsible extraction of raw materials. We're saying, how do we leave less liability in the future and a resource that other people can use in the future? We go right through to the end of this, and we say, what would the benefits be? It's a circular economy. It's a subset of this discussion. I realize I'm really focusing on the open pit and the tailings, but it is a subset. So we're converting waste materials into a resource. That's effectively what we're saying. We're reducing the land requirements for permanent tailings disposal. And as I mentioned at my start of my discussion, I can look out my window here in Santiago and I can see the mountains where these deposits are today that are being planned to be exploited in 10, 15, 20 years. And I know that there's no one in these communities who's going to say, great, you can put a tailings basin over there, sure. I can't see it. Personally, I can't see that happening. There has to be a better way to manage the waste materials that we're generating. Reducing land requirements, and then reducing, of course, the long-term environmental risks and environmental liabilities. So are there case studies? My question is, are there case studies at large scale? How can we convince mine planners to think this way, or really, in effect, get people out of the silos, right? I mean, it's not just convincing mine planners, it's convincing the boards and the technical managers and the social managers, the environmental managers, the people doing consultation, to think more broadly about how to design this. This can be applicable to a greenfield site as well as to a brownfield. In fact, in many cases, I believe brownfield operations sometimes have more opportunity like this because they've already created deposits of waste or open pits or underground deposits in which they can place waste material. So that's really my conclusion. I was going to also show the goals and just say, well, which of these goals are we talking about here? Quite a few of them. If we can do this, we're clearly talking about water and sanitation, keeping water clean. We're talking about actually potentially, we're talking about innovation in number 9. We're talking about life below water and life on land. We're talking about partnership. We're talking about things that will provide benefits to the surrounding community and to the company and to all involved in these undertakings. They are massive, and they will continue. I think the current rate of closure of copper mines today is just slightly lower than the rate of development of new copper mines today. So it means that these projects are being developed pretty much every day as we go. And I'm interested in presenting this proposal to all of you to say, let's push this. I'd like to push it in some way. Don't know how exactly, but I'm starting here. And I think that takes my 10 minutes. And I'm going to open up to whatever questions or thoughts you may have. Thank you.
Brilliant. Thank you very, very much, Norm. And yes, as per usual, you can hear that round of imaginary applause from the other side of those muted microphones. So thank you very, very much for your talk there. Now, as per usual, we have a number of questions coming in. And the first question we have is from Sandra, and she's asking, how can the remining of tailings be robustly included in the mine closure project? So how can you formally bring it into that mine closure project?
Yeah, that's a good question. I mean, as we know, at least with the materials I'm talking about here, like hard rock mining for, say, copper, if we remine the tailings, we still end up with tailings. So we still have to manage the tailings, right? But we can do better things with those tailings, because by remining the tailings, depending on the economics here, we will generate a resource. First, we'll be generating a copper resource or a metal resource. We'll be generating some revenue. We can then manage the tailings that we produce in a different way as well. It's not even mentioned that tailings can be managed with more water extraction than we do today. Many ranges of that, right up to paste production or even solid. And make stack tailings, paste tailings, thickened tailings, so recover water as well. And then put the tailings in a different place, because they will be handled again. So if you're doing that, you can say, now we can look at what other alternatives do we have to use for these tailings. I was recently involved in a very short analysis of possibilities for large-scale tailings deposits, where discussions were brought up about making building materials, making bricks, making sub-base for roads. This requires redefinition of regulations too. In Chile, mine waste can't be used in certain areas. It's called mine waste. So the regulations would have to catch up and say, we're going to take these tailings and use them elsewhere. But I guess, am I answering the question? Yes, reprocessing of tailings can generate revenue, which can allow you to do better things in terms of your final closure.
Great. I hope that answers your question, Sandra. Thank you very much for that one. Norm, we've got another question that's come in. What we're asked here is, storing tailings in mined out areas is a good idea for mines where once resource extraction is complete, there's no possibility for re-entry due to commodity price increases or whatever the case might be. That being said, I believe that mine designs that incorporate tailings disposal within waste dump facilities deserve much more attention. I don't know if you just want to comment on that.
Of course. Yeah, I know. And I mean, I didn't add that in. It's true. You'd have to manage the waste differently, create a liner, make sure that you weren't going to generate environmental pollution from that. Same with the pit deposit. But you're absolutely right. And that was a concern in the project I mentioned, where when we start to put waste back in this pit in 24 years' time, let's say, the planners will say, wait a minute now, you're losing the resource. The resource is no longer available once we do that. That's correct. It's true. So maybe you'd have to look at combining the waste with waste rock in some other setting. It's true. But that may require you to crush the waste rock, create a liner, create a water recovery system, all those goodies. Nonetheless, it's possible to incorporate that in mine planning.
Brilliant. Thank you, Norm. I'm going to actually pass across to Nadia now, because Nadia's got a follow-up question based off that first one that you answered. Nadia, over to yourself.
Thanks, Sarah. And Norm, you just touched on co-disposal, which is part of my question. So I was actually curious on your thoughts on that as we think about you know, the potential for reprocessing down the road. What are your thoughts around how, it just follows from Sandra's question about designing for potential future reprocessing, but how does the co-disposal influence or impede our ability to do future reprocessing if we're mixing together waste rock with tailings?
Yeah, well, I mean, first of all, the goal is to get as much metal out as possible today, isn't it? So if we're talking about a new project today, I realize it's not historic. The historic situation is very different, where there are tailings that are now resources. And we know that all around the world. We see lots of sites where tailings are being processed as a resource, and so are waste rock. But if we talk about a new project, what I've seen in my experience recently is that there's a lot of effort made to get the maximum possible recovery right through to the tailings, so the tailings are not a resource anymore for recovery of ore. And in that case, if you do co-dispose with, say, acid-generating waste rock, you're disposing of something safely, but it won't be a resource anymore. But if you have other material that you feel could be a resource in the future, you have to put that elsewhere. It's true. You have to look at where you would place materials in the future and then recover them. And one project that I've worked on is one where they are going to stockpile that material as waste rock for use in 25 years' time, and then recover the waste rock and call it waste rock of low grade. So it's not actually waste. It's called high grade waste. And by that 25 years' time, we can assume the value of copper in the marketplace is likely to be higher, not lower. So you can't build that in the model yet, but you know when 25 years comes, someone will say, who came up with this closure plan? Anyway, was that Norman? And they say, where is that guy? And I say, wait a minute now, this is an economic project. This is not just cost. This is also recovering materials to do closure. That's the idea.
Well, we've had a lot of discussion about different word on stakeholder. I think we could do the same with waste, because I agree with you. With the term waste is assumes potentially that it isn't valuable, but I think you're absolutely right. That maximizing recovery should be key.
Can I add a comment here on an experience I had in Canada? Actually, I lived in Canada for quite a few years, and I worked on a solid waste recovery project in the Eastern Canada, in Halifax, where they were disposing 95% of the municipal waste from a city of 250,000, and the landfill was filled. No one was ever going to look at another landfill, forget it. And I with another fellow managed a project supported by the regional government to develop an integrated waste management plan, which converted waste to resource. It was called an integrated waste/resource management plan. And the whole idea was to change the paradigm. So people could say their waste, hey, this waste actually has about 75% resources in it. If you take obviously, the paper stream, the recyclables, and especially the organics. And that was set up, and that was done through a paradigm shift. But it required quite a bit of time of education to get there. How quickly does the mining industry change its approach to mine planning? I would say very slowly. But we have new challenges where we can't get things cited. We can't cite those facilities I'm referring to. So you say, good, how do we do it now in a more creative way? So when we cite this, we're saying to people, we are using some of this area as a deposit area. That land will be usable in the future in some way. Now, you won't have houses on it, but you can actually have a level piece of land, which may be productive, right? Depending on the water availability. I hope that answers and gives a bit of insight as to what I've been involved in, because I really believe in the paradigm shift. It's really, really big in this.
Brilliant. So thank you very, very much for that, Nadia, and also Norm, for that brilliant insight and actually bringing an extra dimension with regards to, I think, some of our thinking that we've been going through today. So another virtual round of applause for yourself, Norm, all the way down there in Santiago. Thank you.
Thank you very much.